Let's see, this is 7.8. All right, let's get started.
Please.
So what we're going to do first is talk about a triangle. Triangle with vertices, we have the coordinates of the vertices. So x1, y1, x2, y2, x3, y3. So let me draw a picture just so we have a little visual. Some triangle. There are my vertices. And x3, y3. And we want to find the area of this triangle. So this is similar to when we talked about the law of cosines, and we knew the side lengths of the three sides. We had this complicated formula, sort of complicated formula with square root in it. So we're going to find the area. So before I write the formula, I just want to mention what would be involved if we didn't have this technique that we're going to talk about today. So I would need to find the height of the triangle to find the area. So we can find the base, the length of the base, by using the distance formula on those points. But to find the height, what we would have to do is find an equation of this line between those 2 points. We'd have to find the equation of the line that's perpendicular to the base that goes through x2, y2. So you'd have to find the equation of that line. Yes?
Can you just subtract y2 and y1?
If this is not necessarily a horizontal line. So if that were the case, then yes. But we're saying this for any 3 points. We'd have to find the equation of that line. Then we'd have to find the point here where those 2 lines intersected. And then we have to use a distance formula between those 2 points to find the height. So it's a lot of work. But we can use determinants to find this area. The area is going to be 1/2. And we're going to take the absolute value because we want our area to be positive. 1/2 the determinant. And we're going to turn these points, kind of like we did for our activity on Friday, into a matrix. x1, y1, 1, x2, y2, 1, x3, y3, 1. Take the determinant of that matrix, multiply it by 1/2, and then take the absolute value to make sure our area turns out positive. So we can find the area of that triangle using a determinant. And we're going to connect back to this formula when we talk about 3-dimensional vectors in chapter 10, because this really has to do with 3-dimensional vectors. So nice determinants, easy to calculate. So a nice, easy way to find the area of that triangle. So let's look at a quick example. So let's say we have a triangle with vertices 1, -1, 2, 3, and 5, -3. The area is going to be 1/2. Take the absolute value. We're going to take the determinant of this matrix. 2, 3, 1, 5, -3, 1. And we take the absolute value to make sure our area comes out positive. And this is a nice 3 by 3 matrix. We know how to do this by hand, or depending on if it's in the calculator portion of the test, you could do it in your calculator. You calculated this out, you would get 9. 9 square units. So a nice easy way to calculate an area of a triangle if we know the vertices. All right, questions? Yeah.
What again is the process for finding the determinant of the 3 by 3?
When we do the next example, we'll go through that in the next example. All right, so what if these 3 points were all on a line? So if x2, y2 were down here on this base, what would the area of that triangle be? 0. That gives us a way to test if 3 lines are on, or 3 points are on the same line. So we can talk about our test for collinear points. Collinear just means on the same line. So we can say in the plane, if our 3 points, x1, y1, x2, y2, x3, y3, are collinear, then that determinant, x1, y1, 1, x2, y2, 1, x3, y3, 1, is going to be 0. So we can test, if we have 3 points, we're given 3 random points, we can test if they're on the same line. The way we would do that if we were using tools that we already know is we'd find the equation of the line between 2 points and see if the third point worked in that equation. But now we know stuff about matrices. We all love using matrices, so we want to use matrices for everything. All right, so let's take a look. So we could say R 0, 1, 4, 4, and 8, 7 collinear. And we want to test using matrices. So what this question is asking is the determinant 0, 1, 1, 4, 4, 1, 8, 7, 1, is that determinant equal to 0? Well, let's figure it out. So our determinant for a 3 by 3, remember we go plus, minus, plus. So it's 0 times, I'm going to cross out that column and that row. My determinant's going to be 4 minus 7. Minus, it's always minus the second one, 1 times, and then I'm going to cross out that row and the second column, and I get 4 minus 8. So 4 times 1 minus 1 times 8. And then a plus 1, cross out that row and the third column. 4 times 7 is 28, minus 8 times 4 is 32. That's 0. 4 minus 8 is negative 4, so plus 4. 28 minus 32 minus 4 equals 0. So that tells us, yes, they are collinear.
Yeah, but if you get 28 minus 32.
4 times 7 minus 4 times 8.
Oh, yeah. Yeah, never mind. Got it.
So that tells us those points are collinear. questions there?
Will we be able to use a calculator for these questions?
For 3 by 3, you should be able to calculate a determinant by hand. You will need to calculate a determinant by hand. All right, let's look at one more application of this. We can use matrices now to find the equation of a line between 2 points. So we want to use matrices to find the equation of, going to have this line between (5, 2) and (-1, 0). Thank you. So normally, or the process that we would use with the tools that we already have is find the slope, use point slope formula, plug it into y equals mx plus b, solve for b. Not a difficult process, but now that we've developed a new affinity for matrices, we want to use matrices. So we're going to call the third point just x, y. So those are our variables in our equation for our line. And we want these 3 points, 5, 2, (-1, 0, and x, y, to be all on the same line. So we need the determinant x, y, 1, 5, 2, 1, (-1, 0, 1. We need that to equal 0. Well, let's write that equation. I'm going to say x times, cross out that row and that column, 2 minus 0. Minus, plus minus plus, minus y times, cross out that row and the middle column. 5 times 1 is 5, minus (-1), so plus 1. And then plus 1 times, cross out the top row in the third column, 5 times 0 minus (-2), not 5, 0, plus 2, and that has to equal 0. So here's my equation. 2x minus 6y plus 2 equals 0. X. And that's fine for the equation of line. Yeah.
Isn't the y 5 minus
5 minus (-1). Because I cross, so this 5 times 1 minus 1 times (-1).
Would we have to put that into y equals 1?
No, this is fine. That's the that's an equation of a line. Is this easier? Is this easier, more difficult than finding the slope and plugging into point slope? About the same. All right, questions? Let's go. All right, here's my question for you, since you didn't have any questions.
I have a question.
Oh yeah, no. Just someone.
What if we had a parallelogram? And we're given the vertices, the coordinates of the vertices. How are the area of a parallelogram and the area of a triangle related? Yeah.
Just the determinant of how to put all the 4 points into a matrix.
So the area of a parallelogram is always made up of 2 triangles. So if I divided this in half, And I called this x1, y1, x2, y2, and x3, y3. Couldn't I just find the area of this thing and multiply it by 2? So the area of the parallelogram is just going to be the determinant, the absolute value of the determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. Absolute value to make sure our area is positive. So that's just 2 times the area of the triangle. And we get the area of a parallelogram. So and when you see a parallelogram in your homework, don't freak out because you didn't have a formula for the area of a parallelogram. Parallelogram is 2 times a triangle.